Hello and welcome. I'm Tom Palmer. With me is Terrence Deacon, Professor of Biological Anthropology at the University of California at Berkeley. Professor Deacon.
Hi.
Thank you for coming.
Thank you for having me.
So we decided to talk about your latest book.
The latest book, Incomplete Nature.
Yes.
How Mind Emerged from Matter.
Very good.
And it focuses on the incompleteness of things.
The introduction dwells on zero and how that took a while to enter into acceptance in the Western scientific mind.
Yeah, I think one of the problems we have in the West is the problem of absences. We don't really know how to deal with things that aren't there, but could have been there. So it's reflected, I think it's a great metaphor for our problem, that we developed a mathematical system that was good enough to build the pyramids, the Parthenon in Greece, and a lot of what was going on in Rome. Remarkable capacities, and yet we had a very cumbersome mathematical system. It took millennia for us to understand that you had to have a numeral, zero, in order to simplify the number system, but also to have a means of calculating very large numbers or very complicated relationships, or things like division and multiplication and more complicated relationships. Couldn't do it without the concept of zero.
There was a worry that it was the devil's number.
That's right.
Because you could divide anything by zero and get zero.
And get, or infinity.
Right.
So it becomes a real problem. And so it doesn't behave the same as other numbers. And yet without zero, all of modern mathematics is impossible. And so zero ultimately made the calculus of Newton and Leibniz possible. With it, we can now calculate the trajectories of planets, exactly land ships on some distant moon of Saturn. Those kinds of things are all possible, in part because we've learned to operate mathematically with this very troublesome concept of zero or infinity. And interestingly enough, zero and infinity are very closely related to each other. They can produce each other, so to speak, mathematically. But learning how to domesticate zero was sort of the key to modern mathematics, and it opened up this incredible range of capacities that we have now in science in every possible area that you can imagine. We have this new tool. Now, my view is that our problem currently with respect to mind and life, the origins of life and the origins of mind, is it's a similar problem. We're afraid of the absences.
The gaps.
The gaps. So one of the things I like to point out is that we have this incredible physics. I just finished visiting the Large Hadron Collider at CERN in Switzerland, where they're running particles at each other at the speed of light or near the speed of light to produce what may have been recently discovered, this Higgs boson, the so-called God particle.
Were you there for the celebration?
I was there just before the celebration, interestingly enough. I just came back and I knew they were going to announce things on the 4th of July. It's a pseudo-celebration. They're not sure yet, but they're closer to being sure.
It's a Higgs-like particle.
That's right. So, but the whole point is that this grand, unified scientific view of the world really doesn't have us in it. And by us, I don't mean our bodies. I mean, it doesn't have minds. It doesn't talk about representation, doesn't talk about consciousness, about experience, about meaning, about value. None of that matters for our physical sciences, nor does it matter even in the biological sciences. We want to explain these things, in a sense, without this baggage.
Even though the concepts in our mind can have huge physical effects.
Right, right.
You give patriotism as an example.
Oh, yeah. And religions and all the beliefs that we have.
Right.
The fact that minds have changed the causality of the surface of the Earth. Everything that's happening on the surface of the Earth is radically different than it was before humans came onto the planet. Certainly before living things came onto the planet, things were very, very different. Life changed the surface of the planet. We're now in the process of doing planetary changes without really being in control of it. That's because of minds, because of our ability to represent the world, to anticipate things, to think about how things work, to manipulate the physics.
Do you think that the scientific dualism of Descartes is part of the problem, that we can't seem to get a grasp of the extent that we're changing the environment, and we have a technology that's out of control? Putting the human experience back into the scientific worldview would somehow help to address the problem.
So I think people have all along been trying to do that. We recognize that the hard sciences, quote, view of the world leaves value out, leaves meaning out. And of course, that's what we're missing in this whole process. And yet, just trying to marry them back together has failed. We really can't say, okay, let's put a little mind in here and then machines over here, and the mind and machine will interact. We don't understand what the relation is between the mind stuff and the physical stuff. And that's what gets us into trouble, I think. Descartes really created the conditions for the modern scientific view to take off and to separate out the mental, the experiential, the value from the mechanistic. Made it possible for us to explore the mechanistic systematically and to build up to where we are now. But that truce that was set up, that sort of peaceful coexistence in which you never talk about mind if you're in the physical sciences, and you never really worry about physics or even biology if you're in social sciences or even in psychology in many cases. That division is a problem, because without understanding how those things work out, we just simply are letting one run on its own, independent of the other. And we, of course, constantly talk about values. We constantly talk about the value of the ecosystem, the value of each species, the value of diversity, those sorts of things. But mostly it's in terms of, well, with respect to me. Will I be less happy if I don't have these things? Will my children have a harder time of it if the ecosystem gets hotter and hotter and hotter? We worry about that, but we don't have a sense of how value comes into the world. My own background as an evolutionary biologist made it very clear to me that there's a point at which mind comes into the world, wasn't here on the earth at a certain period of time, and values, morality, comes into the world at a certain point in time. It emerges into the world. It's part of the world.
From matter.
Yeah, that's right. The matter on the surface of the earth being bombarded with sunlight gets organized in such a way that that organization brings this about. And so the fact that we exist means that there has to be a real story to be told about us, that we did come about somehow. The key is to figure that out. The key is to figure out that, yes, indeed, our experiences, our values are really part of the world. They come out of the world. They're not something separate that can't be figured into the physics of the world. We need a bigger physics, so to speak, that is big enough to encompass what we are. Otherwise, we're just alien creatures here.
How do you introduce the organic experience in all its messiness and sloppiness and what have you, and not lose scientific rigor?
It's probably the hardest question we're facing currently. And I would say that I don't feel like I've solved this big mystery, but I've tried to take steps in a direction I think will help. And that direction is to, in effect, recognize that we're not machines in this common sense of the word. We're messy in all the senses you mentioned. We're terribly messy chunks of spaghetti and, covered in this thin sheet. We don't work like machines. Our brains aren't like computers. They're completely messy at base, and yet they're capable of this kind of complexity that we're capable of. What I realized from that is that one had to start from probably the most basic asymmetric process in the world that doesn't seem like it should give rise to us at all, and that's the second law of thermodynamics. The fact that leave things alone and they get more messy, not more ordered. That seems to be probably the most generalizable principle we can talk about, having to do with the directionality of time, the way things change on their own spontaneously. It was necessary to figure out how a process that tends to produce disorder when you leave it alone can, under certain circumstances, produce more order. and how processes that can produce more order under certain combinations can produce the special kind of order that is a living process or a mental process. And that means building it up from this, you might say, counterintuitive basis, from a system that tends to get less organized over time. For the most part, the universe, when we leave things alone, things get messy. We don't take care of our cars or our rooms, things go wrong.
But you equate that to freedom. You talk about entropy and you talk about order in ways that make you see them in a different light.
Right. I think one of the problems we have in terms of the ideas of freedom and free will is that we don't really want to be caused. We would like to be the authors, so to speak, of everything that happens. Well, in one sense we are, and in one sense we're not. And what people tend to forget is that if we had a world that did not allow causality, that did not have this determinism that we think about, then it would be like trying to move a ball or a chair with a string. You can't push things with a string because they have no solidity. They have no guarantee that something is going to happen. We needed causality in this story. We needed some kind of predictable way that things determine other things.
But you do describe it as less freedom.
So, in one sense, it seems like what I try to argue is that, in fact, we have to invert this aphorism that dates all the way back to the philosopher Aristotle, that the whole is more than the sum of the parts. We like to think that myself, my being, my consciousness, my soul is more than the sum of my parts. I've actually inverted that in my thinking, that the whole is actually less than the sum of my parts. In fact, less than the sum of those parts in all of their possible interactions. Now, to give you a sense of this, think about a car's engine. A car's engine is physics as usual. It runs. The question is, where is the function of the car's engine? What's its function? Well, we can say, with something I want it to do, I want it to move me across the ground at a certain rate if I put in enough gas and get it running. How do I know when the engine is functioning? Well, when it does its normal physics. No special physics there. The function doesn't depend on any magical physics. In fact, what it depends upon is what the engine is not doing. In fact, if the pistons get loose and they wiggle around, if the valves don't work quite right, the engine will stop working. In fact, I've made it function by virtue of limiting the degrees of freedom that all the parts can move. I limit them very precisely, and now I can get function out of it. And in fact, when I add freedom, when I loosen these bolts here and there, and I allow things to wiggle around, it stops working so well. Function begins to disappear. Function is actually there because of what I have not allowed to happen. Now think about your body and life. We oftentimes think about our lives as something more than my body's function, that my life is more, and when I die, it will go away. I'll lose something in this process. But actually, the molecules are each making each other in this marvelous circle in which one molecule makes another molecule, makes another molecule that makes the first, in a complicated web of networks that do this. They are constrained. They are limited in what they can do. And it's those limitations that allow them always to make the same things, to always produce this body that looks the same even though it's replacing its parts constantly. What happens when I get sick and I begin to decay and break down and eventually die is that those constraints, those limitations are actually being loosened. The molecules are able to do more things than they could have before. They've gained degrees of freedom, and in that process, the function, life, disappears. It's not the loss of something present, it's actually the loss of the absence, in a sense, the constraint, the limitations on what could happen, or what made me possible, less than the sum of the parts and even all of their possible interactions. That's what I am. It's recognizing that I was looking in the wrong place. I was looking for something more, something extra, when it was actually something missing that was important. That helped me also to think about issues of meaning, for example, and reference. Because something that means something else, the meaning is absent from the words, from the sounds I'm saying now. The meaning is not in the sounds. And I would say that the meaning is not in my head or your head either. It's not the stuff that's going on. The meaning is something that's not there, that all this stuff represents. All these concepts are not in your head, not in my head. If I describe something, it's not either one of us. But it's absent. And it's precisely absent because of what's present. And what I realized, it's the particular constraints on what's present that's generating what's absent. That's the important story. And I needed to be able to build physics in such a way that you could come to that assumption about you and I, how our bodies were able to, in a sense, create the right kind of absence to make meaning possible and ultimately to make consciousness possible.
So are you looking for laws to describe these the entropy and how understanding entropy can, say, get the human experience back into the scientific equation?
Right. So in other words, to do this scientifically, you have to have a clear understanding of exactly how things are working, what the rules are.
And what have you
So the first
concluded?
clue to this, I think, has been known for a generation now. And the first clue, and it's been explored extensively by lots of people, is what happens when a physical system, for example, is constantly perturbed, constantly set off of its equilibrium. It's tending to go into mess, tending to just become disordered, but you continually perturb it. So, for example, I like to think about a whirlpool, the simplest example you can think of probably. You put a rock in a stream and it pushes water to the side, and as it comes around the rock, it tends to form a circle. And that whirlpool now has a regular pattern to it. It's regular because you're constantly putting new water into it, and you're constantly pushing the water off to one side, and it rebalances itself. The whirlpool stays there, but it's not the same whirlpool second after second after second. This is Heraclitus and this idea that you can't put your foot in the same stream twice. This whirlpool is not the same whirlpool twice, and yet it is. What's maintained there is the structure, is the dynamics of it. It has that feature never changes. But the dynamics is not the stuff. The dynamics is how the stuff relates to each other. It self-organizes in the sense that I don't have to force it into a circle. It tends to go circular, in part because there's less work being done for the water to move through the system and rebalance those disturbances of movement as it does this. That's what we call a dissipative system. You're perturbing it, and it's getting rid of that perturbation as fast as it can, as simply as it can. Things can become more orderly in the process of trying to get rid of order. That's called self-organization. And it happens in all kinds of interesting ways.
Autopoiesis?
Autopoiesis is different, and I'll come to that in a second.
I see.
It's in fact one of the confusions that I tried to overcome in the book. Autopoiesis is sort of a description of what life must be doing.
So now we're getting into life. A lot of these mechanics are inorganic.
Right, and I think you first of all have to understand the inorganic ones.
The distinctions first, and then you get to the organic.
Then you get to the organic,
see.
Because in one way, the organic is fundamentally different. So if you say autopoiesis is what life does, yes, it self-organizes in a sense, but it's not quite like a whirlpool. Now, if you think about a whirlpool with a finite amount of water upstream that's going to run down, the whirlpool will actually allow it to run down faster than if it was just chaotic. Things that self-organize actually use up this disturbance faster. So if you want to create something that generates order, as it becomes more orderly to get rid of that imbalance as fast as possible. And so self-organizing processes are actually self-undermining processes. They actually speed up the process of breaking down the conditions that create them. Life can't work that way. Life cannot persist if it's continually undermining itself in such a way that it will eventually destroy its base. And yet, we partially do. The question is, how do we do that and something more? And this has been the challenge. So self-organization, whether it's the spontaneous growth of the incredible order of a snow crystal, which by randomly accreting Water molecules can become highly ordered because of the way previous cycles of accretion of ice constrain later cycles of it, how the temperature and the humidity and the pressure determine how the crystal is going to form. Its incredible symmetry is a self-organizing process because it too is dissipative. It's giving off heat constantly. You're continually pushing it off equilibrium by adding more ice particles to it. And it develops order. The nice thing about snow crystals is that they freeze that order, at least temporarily. We sort of freeze the order too. Interestingly enough, we generate order and we don't allow it to break down.
In our bodies?
In our bodies, we continually replace this process. So we're doing self-organization, but self-organization that never allows itself to use up this capacity. In fact, our bodies are set up in such a way that if we run out of food, we go find more. If we are not warm enough, we go try to find a way to warm up, and so on. We're organized in such a way to compensate for this very problem that self-organization creates. And yet, we have to create order. Our bodies have to be order creating, but they have to get away from this problem of self-destruction that the inorganic forms do. What I realized in the developing of these ideas is one of the things that is crucial to organisms is that they use self-organizing systems against and in favor of other self-organizing systems. We're coupled self-organizing systems that create each other's what we call boundary conditions. A boundary condition are the conditions that make it likely for something to happen. Sometimes they're called boundary constraints. They're the limitations on the physical processes, the chemical processes, that make some things happen but not others. And the advantage of something that produces order, like a self-organizing process, is that it produces constraints. Order is constraints. It's a limitation of the variety. And if you have two systems that each produce the kind of constraints and the order that supports each other, then you have a system that now, in effect, generates its own internal constraints, its own internal order. And that order can now compensate for the fact that it's potentially using up its constraints outside. That's what I call teleodynamics. And let me sort of describe this hierarchy that we call this sort of tendency to fall into mess thermodynamics because of the way heat does this, the way heat distributes and dissipates, worked out throughout the 19th and early part of the 20th century. This self-organizing process, sometimes it's called complexity theory, chaos theory, they all contribute to this, or systems theory. I like to call these processes morphodynamic. They're dynamics that produce forms, morphologies. Special interactions between thermodynamic processes can produce processes that, under some circumstances, produce as a side product, effectively, regular forms. When regular forms can produce each other in this sort of reciprocal way that I just talked about, I call that teleodynamic, end-directed dynamics. Because what's happened is that now they contain within themselves their own ends, so to speak. Each self-organizing process is both an end and a means for the other self-organizing processes. And this creates a kind of interesting structure that we would call a self. That is something that contains its own constraints, its own limitations, and represents its own limitations. If disrupted, it will form them again.
We do this physically in our bodies, but we also do this mentally with our consciousness.
Exactly. One of the problems of explaining the
and there is your in, yes?
That's my link.
Yeah.
Exactly. That one of the problems we have explaining consciousness is this notion of what myself is. You know, what's the I that's having these experiences, that feels like the recipient of the experiences and the agency of my actions, that seems like a special locus? Well, it always seems to be something that we have to pass on down. You know, maybe it's this little guy in my head. But if there's a little guy in my head that's doing this, there's a little guy in his head that's doing it, and a little guy in that guy's head that's doing it, and there's no end to these little men that are doing this work. That can't be the kind of answer we want. We want an answer in which the dynamics itself, the way this reciprocity works, is creating a locus of self, something that's a continuity with respect to which there's an other out there, a world that's different, that doesn't have these features, something that tends to reform itself when it's disturbed, and so on. That's the same problem for life and mind. And so in bringing this together, and I'm not the first person to see that there's probably a link between the nature of life, if we can really understand the basic nature of life, we should have a hint as to what the basic nature of mind is. Because you need self. You need something that's continuous, with respect to which there is other. Therefore, you need to maintain the constraints that keeps the function, that has a locus that's never disturbed, or that when it is disturbed goes back and sets itself right again, and does so spontaneously. That's what you need to start life, to begin life on the planet. In the simplest sense, you need a very simple way that these kinds of processes can take place at the molecular level to create that kind of reciprocity. But as soon as it's there, you have self. And a self that has to continue itself, has to maintain itself, has a couple of interesting features. Number one, it has to get something from the outside world because it's continually running down. It has to get something from the world. And the second thing is that it's separate from the world. It's a self. And so there's a self and an other. That's got to be true for a living organism as simple as a bacterium, as well as for a conscious mind.
Well, I'm just told we only have a couple of minutes. I wanted to ask you about emergence and whether
that's sort of what
your
we've been
understanding of
talking about.
emergence is similar to, say, Michael Gazzaniga's.
I think the term emergence has been used all over the sciences. And it basically refers to how some novel process, novel way of changing things in the world, a novel way that the world works or novel functions can sort of show up without antecedent. Life is one of those. Life emerges from non-life spontaneously with very, very different predispositions. So if you think about self-organizing processes that I just described, we know that they can emerge under special conditions when thermodynamic relationships are set up with respect to each other. You can produce these dissipative form-creating processes. When those kinds of processes are brought together in just the right way, you can also produce processes that maintain themselves, that literally have a self that they will reproduce and reconstruct over time. Each of those is emergent in the sense that radically different properties begin to show up in the combination. So in the first case, going from a simple thermodynamic system to one that's self-organizing, suddenly you're not seeing something that always gets messy and more messy over time. You're also seeing that in that context, there's also a part of it that gets more organized. In life, you see something beyond that, because those things that get more organized are doing so on the basis of eating up their basis, eating up the gradients that drive them. But in fact, a living system has to reverse that as well. Therefore, those properties emerge out of, in a self-organization. So I see really two clear levels of emergence. And by emergence, we mean, again, something without precedent. Now, not all living things, of course, are conscious. What happened as living things became more complex and developed brains, a new kind of self emerges. A self that is both within organisms, but has totally different kinds of properties. Not like a bacterium, not like a plant, but has a self in a much more direct sense, in a kind of a model of self as well as self.
Thank you.
All right.
Well, Professor Deacon, we're out of time. There's much more I'd like to talk with you about. Perhaps you'd be good enough to come back and we could speak in detail about your first book, which I found fascinating and which focused on the evolution of the mind itself.
All right, thank you.
Yeah, very good.
Happy to do so.
All right, thank you, sir.
All right,
All right.
thanks.
And thank you for watching. Good night.